Friends, good morning. This is Elements of Analysis Model. In the element of requirement analysis, there is 4 types software requirements. First, scenario-based models. In that, we are learning use cases and user stories. Next is class model. In the class model, there is a class diagram, collaboration diagram. Next, behavioral model. In that, state diagrams and sequence diagram. And last one is flow model. In the flow model, DFDS and data models. Friends, in the scenario-based elements, there is a use case diagram, activity diagram, and swim lane diagram. In the second, flow-oriented elements, there is data flow diagram and control flow diagram. In the third, behavioral elements, in that we have to learn state diagram and sequence diagram. In the fourth, class-based elements, class diagram, analysis packages, CRC models, and collaboration diagrams. First one is scenario-based modeling. In that modeling, the analysis modeling is at the beginning, creation of scenarios. In the form of use cases, activity diagrams, and swim lane diagrams, it occurs. How to write use case diagram? In the use case diagram, it represents the overall scenario of the system. Scenario means a sequence of steps describing an interaction between user and a system. Use case diagrams are drawn for exposing the functionalities of the system. In the use case diagram, there is an actor. Actor can be a user of the system or an external entity that gets some value or produce some value, that is a device, an enterprise, etc. interacts with the system. A single actor may perform many use cases, or a use case may have several actors. This is the notation or simple diagram of actor. An actor is rendered as a stick figure in a use case diagram. Each actor participates in one or more use cases. This is notation of use cases, represents behavior of the system. Various functions can be represented as use cases as shown in the figure. This is a simple example of use case diagram where student and faculty, these are the actors, and registrations, updating grades, output generating, these are the use cases. They are connected to each other. Relationship between them. First one is association. Association identifies interaction between actors and use cases. Each association represents a dialogue. Include relationship, identifies reusable use cases, that is unconditionally required for the execution of another use case. Extend relationship. It identifies a reusable use case that conditionally interrupts the execution of another use case. Generalization. It identifies an inheritance relationship between actor or between use cases. This is the example of ATM machine system where there is an actor, administrator, bank customer, and bank. The system maintenance, system reporting, system shutdown, these are the use cases connected to each other through include function and the login transaction. These use cases are connected to include or extend functions. Transactions, in the transaction, there is a withdraw, check balance, deposit, and print receipt. A use case with most of scenarios found in use case diagrams, that is customer, NRFC customer. Suppose customer want to open the account in the bank. Then there is a many use cases. First one is open account, deposit funds, withdraw funds, then calculate bonus, update balance, and finally convert currency. Here include and extend functions are used. Activity diagram. It represents flow of interaction within specific scenarios. It is similar to flow chart. This diagram must be read from top to bottom. It consists of 4, allows multiple activities to be carried out in a parallel, branch, where multiple branches open, merge, where multiple branches get combined and joined, comes before transitioning into final activity. Activity diagram is essentially a flow chart showing the flow of control from activity to activity. Use activity diagrams to specify, construct, and document the dynamics of a society of object or to model the flow of control of an operation. Activity diagram emphasize the flow of control from activity to activity. An activity is an ongoing non-atomic execution within a state machine. The UML user guide. This is the activity diagram where start is the initial node. First of all, we receive order and first activity is going to divide into 2 activities by the use of 4. First activity divided in authorized payment and check line team by using 4 and go to the next operation that is assigned to order. Again by the use of 4, we are dividing it into 2, dispatch order and recorder item. Here, suppose the operation is failed, then we go to the cancel order, and if operation is success, we go to the final dispatch order. This is activity diagram verified password ATM. Like this, where start is initial node, go to the first activity, a client, retrieve client card number, a pin, and go to the decision box where if pin is not there in the this diamond shape, it is a branch which is called as decision box. If there is a yes no conditions at the time we are using this branch or decision box. If yes, go to the further final process. If no, that means here pin not valid, we are going to the display incorrect pin, please try again activity, and if pin is valid, if yes condition, then provide access to the account. And finally, by the use of joint, we are joining these 2 outputs and gives one final input to the end node. swim lane diagram. In this diagram, activity diagram is partitioned according to the class. Who is responsible for carrying out these activities? The swim lane diagram is same as activity diagram, but here we have to mention the name or the authorization, that means who perform these activity operations. That means in this diagram, customer, ATM machines and bank, these three organizations perform their personal operations or activities, and these three are called as swim lane, and we have to differentiate these three in the form of box, from which we can easily understand the three activities or organizations operations easily. That means here customer start node, insert card, then enter pin for the ATM machine, and in go to the authorized bank. If in the bank pin is valid, we are going to the check account balance, but if pin is invalid, we go to the eject card. Like this, suppose there is a invalid condition, then we are going to the finally decision box and eject the card. If pin is valid, we can authorize it. Similarly, if pin is valid, we are customer go to the enter amount by the generation. After entering the amount, he again goes to the check account balance. If there is a sufficient balance, then withdraw amount. If balance is not sufficient, then again go to the show balance. And if there is a balance present, we or customer take money from a slot. Finally, these two take money from slot and debit account, these are joined together with the help of fork and go to the final decision box, show balance, and finally eject the card. Thank you. Thank you for watching.